prove this equivalence, we shall first suppose that the model admits an arbitrage opportunity. That is, there exists self-financing trading strategy phi such that the value of phi at time naught is non-positive, the value at time 1 is non-negative almost surely, and the value at time 1 is positive with positive probability. That is the definition of phi being an arbitrage opportunity. Therefore, value of phi at time 1 is equal, by definition, alpha S1 plus beta B1, where phi is beta alpha. That's equal alpha S1 plus 1 plus R B0 beta, by definition of how the risk-free asset works. That's equal alpha S1, just a little bit more manipulation, 1 plus R, beta times V0, beta times B0, sorry, is V0 minus alpha S0. Of course, that's just how the value of phi at time naught is defined. And this, again, moving around a bit, 1 plus R, we have here alpha S0 plus V0, 1 plus R. Let's make that clear again, that that's V0 phi, 1 plus R, just separating those things out. Since V0 is less or equal 0, this is less or equal alpha S1 minus 1 plus R alpha S0, almost surely. Well, yes, I guess it should be. Well, it's not really almost surely, I think it's even just for all omega, but, well, it doesn't hurt. By assumption, alpha S1 minus 1 plus R alpha S0 is greater or equal, V1 phi, is greater or equal to 0, almost surely, right? That's what the calculation we've just done here. And 1 plus R alpha S1 minus 1 plus R alpha S0 is greater or equal, exactly the same, V1 value at time 1 of phi greater than 0 with positive probability, which is what we needed to show. Now for the other implication. So we shall suppose that such an alpha exists. Let Q be an equivalent measure to P. Oops, that I should write that a little bit clearer. We shall show that Q is not a martingale measure, and then it'll follow from the first fundamental theorem of asset pricing that the model is not arbitrage free. Okay, then expectation under Q of S1 over 1 plus R, discounted price of the risky asset at time 1, is equal to 1 over alpha, expectation of Q alpha S1 over 1 plus R, nothing fancy there, just multiplying and dividing by alpha. And this is greater or equal, by assumption, 1 over alpha, expectation of Q alpha 1 plus R S0 over 1 plus R. We have assumed that this is taking the alpha from the assumption that these two properties hold. Since it's true almost surely, then it's certainly true in expectation. Now we have from this that no, sorry, that's not what I want to write. We also have that under Q, alpha S1 is greater than 1 plus R alpha S0 with positive probability. So we've got then these, I've divided both sides by 1 plus R, but it's irrelevant because it doesn't change the monotonicity, of course. We have two random variables. One of them has expectation which is greater or equal to the other, and it is greater than the other with positive probability. It follows then that the expectation of S1 over 1 plus R is not just greater than or equal, but actually is strictly greater than the expectation of alpha S0 multiplied by 1 plus R, but also divided by it, which is just equal. Sorry, this should be an alpha here. And that's moved on the inside. I'm trying to replicate what we had above. So this is actually just a strictly greater. And of course, the expectation here is unnecessary because S0 is S0 is deterministic. So since one expectation is greater or equal to the other, and one is greater than the other with positive probability, the expectation is actually strictly greater. So Q is not a martingale measure because the discounted asset price is not a martingale under Q. Thus, first fundamental theorem of asset pricing tells us that the market is not arbitrage free. That's the word not.